Hello, everybody, and welcome to the Fall Protection Week. We're going to talk about a couple things with fall protection today. And I'll be honest, this is one of my favorite topics to go over, so I was really kind of looking forward to getting to this point. So topics we're going to cover, we're going to talk about the regulatory requirements, exactly what Subpart M does say, safety monitoring system, guardrails, personal fall arrest systems. We'll spend a lot of time on PFASs, controlled access zones, safety netting, ladders, scaffolding, etc. So that's kind of the agenda of the stuff that I'm going to go through. So jump right in. When you look at why fall protection is required, it's because it's the #1 cause of death in constructions. So if you look on average, there's 700 deaths per year because of falls. In general industry, that's the second leading cause of everything. Fall protection is also the most commonly cited standard. If you go and start looking up construction companies and their OSHA citations, a lot of times you'll see that they have fall protection. Either the people didn't wear it, people didn't train on it, they didn't use it right. So a lot of different reasons that all comes together. So then the question usually comes up, when is fall protection required? And that's where you start getting some confusion. If you are in a position where you could fall into dangerous equipment, then you have to have fall protection all the time. So example, with this picture, there's water in there, it could be filled with alligators, who knows? You really don't know what's in there. The fact is that if you have that hazard, you have the potential that you could fall into a hazard. So it could be rotating material, it could be flowing material, it could be water, etc. You have to prevent the fall, period. No questions asked. If you look back to regulatory compliance and their general industry requirement, their requirement is you have to have a fall protection of some sort on at 4 feet. So we get into construction, and all of a sudden that turns into 6 feet. So anybody working on a working surface more than 6 feet has to be protected from falling. So that's 6 feet in construction. Unless you're working on scaffolding. We just talked about scaffolding. Scaffolding is required at 10 feet. Well, that's because a buck of scaffolding, one section is usually about 5 feet tall. So they say, okay, you have to wear it after the second, once you get to a second section. So scaffolding is 10 feet. Steel erection, we're going to be getting into steel erection, but at steel erection, then you have to wear it at 15 feet if you're, unless you're the connector, and that's the person actually putting the nuts and bolts all together, then you have to wear it at 30 feet. So hopefully everybody understands that this can get confusing. That if you could fall into a hazard, it's 0. If you're in general industry, it's 4 feet. If you're construction, it's 6 feet, unless you're on a scaffolding, then it's 10 feet. Or if you're doing steel work, then it's 15 feet, unless you're a connector, then you have to wear it at 30. So a lot of companies have went to a set 4-foot or a 6-foot rule for fall protection. If you go on any of the big players in this area, they're going to say fall protection is required at 6 feet. Doesn't matter what you're doing or where you're at. They have a very set 6-foot fall rule. So again, if you could fall into a dangerous equipment, it's 0. General industry location, it's 4. Construction location, it's 6. Scaffolding, it's 10. Ironwork, leading edge work is 15, but steel erection is 30 feet. So there's a lot of confusion. When I teach a class like this for general industry, they may say, well, why is the difference? Or why do I need to know what construction says? Well, it's because you're going to have contractors coming into your site, and they're trained on a 6-foot rule. They may not be trained on a 4-foot rule. They may not be equipped for a 4-foot rule. It's your requirement, or it's your responsibility to make sure that they understand the requirements. The next type is a safety monitoring system, and I think this cartoon kind of wraps up my opinion of it. What a safety monitoring system is it's primarily for roofers, for flat deck roofers, where they have somebody sitting on the edge to say, okay, you're getting too close, you're getting too close, don't fall. And you can see how well that would work. Now the problem is that the best person to be in that position would probably be a foreman, a journeyman, a superintendent, somebody with some authority to it. But you could probably imagine who's going to be the person that's going to be in that position. It's probably going to be the cheapest person, so it's going to be the newest person. And the newest people aren't going to step up to the senior most people very often. So This is allowed. It's in the regs. It's not something I necessarily recommend, though. Guardrails are the preferred method of fall protection. This is where we start looking at our hierarchy of controls. We are engineering out the hazard at this point. We are making it that they cannot fall. So a couple things you have to know. First of all, your railings. Your railings have to be 42 inches high, plus or minus 3 inches. You have a mid-rail in there that's halfway. So it's 21 inches plus or minus an inch and a half. These have to withstand 200 pounds of lateral force. So hopefully you can see my cursor. As you are pushing this way, I think I can draw this. As you are pushing this way, you have to, it has to hold 200 pounds. And that's important because that's what's actually going to keep you from falling over the edge. Hold on. Sorry, a little technical difficulties there. So here's another picture of a good guardrail system. So you have your top rail made of 2x4. This got your mid rail, 42 inches, 21 inches, and then the very bottom. Okay, let me draw this out a little bit. So up here, 42 inches. Up here, 21 inches. Notice right here, this is this is your toe board. Your toe board is there to keep things from getting kicked underneath. That toe board has to be 3.5 inches tall. So the reason it's 3.5 inches tall is that way you can use a 2x4. If you don't know, a 2x4 is actually 1.5 inches by 3.5 inches. That's the actual size of a 2x4. So that's why that is. You only need it there if you can have something that could fall on somebody else. The standard is that you always have it, but it's not necessarily required. For example, you look at these guardrails. These are going to be very, very popular. You have these little base plates here. Got one right there. One right there. A couple more here. Those base plates with these guardrails make a fully compliant system. So they could be easily set up. They can be moved to different job sites. The plates are kind of a pain in the butt. You have to get those up on the roof, for example. You have to get those up on a roof. Sometimes you have to crane them up. Sometimes you can just take them on a forklift. But they meet all the requirements. Something else that you can do with guardrails is if the parapet is the part of the wall that, or on a roof, the parapet will come up higher than it. It kind of makes a kind of a wall type item. If that's 42 inches, then you don't need guardrails. If it's less than 42 inches, you have devices that they can actually clamp down. You put 2x4s in and make it a guardrail that way. There's all kinds of options, but you have to have something on the roof as well. All right. So now we're going to get into our personal fall arrest systems. And with that, we have to talk about fall arrest versus fall protection. Fall arrest is basically keeping somebody away from the hazard. So think of a dog on a leash. The dog can go so far, it's going to stop, so it can't actually get onto the sidewalk. It can't actually get out into the road, whatever the case is. It can only get so far, but it can travel along that leash. Fall arrest, it actually stops the person once they've started to fall. So with that, fall arrest prevention is always preferred. We don't want that person to fall if they don't have to. If somebody falls, it's a lot of force on their body that we don't really want. It's painful. Falling can be very, very painful. We want to prevent that. So when we talk about our fall arrest systems, we want to think about our 4 different components. And we want to think A, B, C's, and D's. So we have our anchor, our body harness, our connector, and our descent. So starting off with our anchor, a fall arrest anchor point has to be rated at 5,000 pounds per employee attached. So a very, very high amount. Fall restraint only has to be 1,000 pounds. So why the difference there? Well, it's because the fall arrest is actually designed to stopping somebody once they've started falling. The force that's going to be put back on that anchor is going to be whatever their mass is times the acceleration of gravity, which is 9.8 meters per second squared. They're going to be pulled that fast. That's a lot of force generated. A restraint anchor must be at least 1,000 pounds because it's only designed to stop somebody basically from pulling it out of the wall. That's what the difference is for. There's all kinds of different anchors out there. Going to my little marker again. So we have something like this. That's just a beam strap. That's just it gets wrapped around the beam and you can tie off to it. This one here gets put onto an anchor, onto an I-beam, and it can actually be pulled along with the person. This one right here, that's something that would be permanently mounted into the roofing system. So if you're getting too close, you can just tie off right there, and it's going to give you an anchor point. Up here, we have a pipe clamp. Now we have to be very careful with pipes. There are certain pipes you can tie off to, and there are certain pipes you don't want to tie off to. It all depends on what the chemical is, what's flowing through there. What is the pipe made out of? If it's a PVC style pipe, not something you want to tie off to. If it's a Schedule 40 steel pipe, that may have enough strength to really hold you up. The biggest thing is talk to your engineers before you start tying off to stuff like that. And then you have anchors like these, which go into spancrete. Basically, you pull this little handle away, pull that back, this part collapses, and then you can put it into a hole you drill into spancrete. Clear all this out. If you notice, this has a capacity of 5,000. This has a capacity of 10,000. Well, the reason for that is the one on the right, the 4077, that has the higher capacity. That way you can tie two people off to it. So that's the type of thing you need to think about when you're looking for fall prevention systems. There's certain things you don't want to use. And I bring all of these up because I have seen all of them. You don't want to use conduit. Conduit is just, it's aluminum or galvanized steel piping that holds the electrical. There may not be a whole lot of insulation. You pull down on that, you could actually get to the point of shearing the conduit, getting it into the energized electrical equipment, and then you've just energized your entire conduit system. Usually your conduit is grounded. Piping we talked about. Some piping is good too, some isn't. You want to know what's in there and really you want to talk to the engineers to make the decision. Sprinkler pipes. These have a way of causing a lot of damage if you break them. There's two different types of pipes. It could either be a wet pipe system or a dry system. Either there's water in it or there's not. But really, once you break the pipe, it doesn't matter. You're going to get water flowing out. And it's going to get really, really messy. And it's going to be very difficult to turn off. So you don't want to do it. Also, the little anchors that hold the sprinkler pipes in place they're not designed to tie off to. They may not have a 5,000 pound capacity. They're designed to hold the pipe, and that's it. The last one is false ceiling structures. And this one may seem kind of funny, that why would people do it, but I've seen it. It's like, well, I'm tied off, what do you want? All that's holding up the false ceiling structures, there's a small little piece of wire holding up at the joints, and then the stability of the structure itself. As soon as you take that stability out, your structure is going to collapse. So you don't want to be tying off to that either. Couple things you want to take a look at. You want to take a look at the location of the anchor. Is it going to be at your feet or is it going to be overhead? How tall is your lanyard? How long is your acceleration device? What's your stretch, etc. At the end of the day, you want to ask, can your anchor hold a 5,000 pound truck? Now, this is for a competent person anchor. This is that you can go through 16 hours of training, and 16-hour training, you're a competent person, you can inspect things, you can identify hazards, etc. If somebody is an engineer or they're what's called a qualified person, they can do the math to bring that limit down. An engineer can say, by tying off at this point in this area with this device, all that together, all you need is 1,800 pounds for that. But that requires a PE stamp, or it requires you to go through additional school. A lot of the fall protection companies may offer these schools, but it's there's a lot of high-level math. It's looking at calculus. It's looking at the torque of pulling a anchor point. Well, here we got this next picture. If you look at this, grab my little marker. And this is actually an engineered system where you have a tie-off point here. You have the vertical life or horizontal lifeline here. So this person is working. If they fall, they're taken care of. But for example, we have a lifeline stanchion here. We have a lifeline stanchion here. Sorry, this isn't straight. You get the idea. And we have our little tie-off wire here. Well, if somebody falls, change this over to green, what's going to happen is this is going to bend this way. This is going to bend this way. And we will end up putting a rotational force on both of these. We'll put a rotational force on both of those. You have to be able to calculate what the force is on there. So, excuse me, I have to pause this and take a phone call. All right, well, I'm back. We're going to get into the second part of a personal fall arrest system, and that would be the body harness. So we've talked about the anchor. Now we're getting into the body harness itself. A couple things. One, you have to wear a full body harness. There's no body belts around or allowed. They are still around. They may even still be allowed for for positioning, but every place has gone to full body harnesses, and that's just because of the forces that are put onto the body. If you're just wearing a body belt, all that force is put right around your abdomen, and it doesn't work. It turns into a fatal injury. Where if you look at a full body harness, it distributes the force everywhere. You can get some with a lot of different D-rings. There's one primary D-ring that's going to go in your back between your shoulder blades. Next thing is you got to make sure you know the weight limit of your harness. Typically these are 310 pounds, but you may be able to get some that go up to 425. Now the important thing to remember is that's not 310 pounds when you get into the shower in the morning. This is 310 pounds of working weight. So it's you, it's your whatever clothes you're wearing. If you're out in the winter and it's Carhartts are heavy, that adds weight. Whatever tools you're going to have attached to you, all of that counts or adds up to the weight. There's also a lot of different types of harnesses that are out there. You have to choose the harness based on whatever it is that you're doing. So here's just a couple of examples of harnesses. So if you see this one, again, let's put on my little marker. We got a lot of different hooks on this one. Back behind here, behind there, and behind here are going to be your back D-rings. Change color so we can see a little bit better. This D-ring, this D-ring right here, that's your front D-ring. I have found that to be about the most useful D-ring there is. There are so many things that you can do with that front D-ring that I never imagined before I started using it more. You can tie off to systems. You can use that to lower yourself into confined spaces. There's so many things you can do. I will not buy a harness for a person without having that front D-ring again. That's just kind of how important I think I found it to be. Then you have these side D-rings. These are primarily for positioning. You can hook something between the two of them. You can tie off into ladders. The linemen, the guys that climb up on the high lines, the electrical lines, they have the ropes that they tie off to. You have these up on top. These are confined space rescue rings that you can actually put a spreader bar and pull somebody up that way. A lot of different options. You even have something like this. Look at these two side rings all come together. This is what's called a bosun's chair. So if you have a window washer or something like that, it gives them a chance to sit in here. Now you have to be tied off. It's actually tied up separate. There's a lot that goes into it. but you have the ability to do a couple of different things with this. All right. After this, we get into our connectors. And we really have two different options. We have a lanyard and we have a self-retracting lifeline. The lanyard is a flexible line or rope, wire rope strapping, something like that that has a connector at each end that you can hook from the anchorage to your body harness. So you have this is your C, it's your connector. A couple things with this, you don't want to tie it back upon itself, and you can't tie them in knots. There's also a lot of different connecting points. There's a lot of clips that you can get. You have to match it up. You can get really small clips. You can get giant clips that will go into rebar, into ladders, etc. You have to pick the right one. And then you don't want to knot or tie around sharp edges. I got a little video here to show as well.
Hi, this is Mark. For this quality control exercise, we're going to use a standard 2-inch 2-ply heavy-duty sling. The vertical lifting capacity of this sling is 6,400 pounds. Remember, we're trying to achieve a 5-to-1 ratio, which would equate to a 32,000 pound braking.
I don't know how it's coming for you guys. Let's turn it up a little bit.
This example is a brand new nylon sling that you previously saw being made in this video. Notice the stretch of the nylon during the brake test. You can actually hear the thread popping prior to the overall failure of the new sling during this test. Notice that this sling broke at the load splice, which is the weakest point of the sling. This sling broke at 32,500 pounds, which is above the targeted 5-to-1 ratio of 32,000 pounds. This next example is a new sling with a 10% edge cut. This time, the sling broke at the 10% edge cut, which was the weakest point. The sling made it to 18,800 pounds, which is well below the targeted 32,000 pounds. This resulted in a 40% decrease in the overall strength of the sling. This next example is representing a face cut. This face cut is only a slight cut on one ply the entire width of one side of the sling. The face cut sling broke at 23,800 pounds. This resulted in a 27% loss of the overall strength of the sling. This next example represents a 2-inch 2-ply with a knot. The use of a knot to shorten a sling is prohibited by OSHA. As the knot tightens, it actually cuts into itself, causing a failure in the sling. sling with a knot tied in 13,000 pounds.
This is about a 60% loss in the breaking strength of the sling.
As you can see in all the examples, damage from normal everyday use can greatly decrease the overall breaking strength of the sling.
Thanks, Mark.
Thanks, Mark.
All right, so I like showing that video when I do training because it shows, I mean, it's really designed for slings, but it meets the same criteria for lanyards as well. So all the damage, you wouldn't probably have thought that that little bit of a face cut, how much damage that could be, or that that tying a knot into a harness could be so devastating to the lanyard. So I like showing that video. Now, one of the things we talked about, you can't tie it back upon itself. There are specific lanyards that are designed for that. So if you look at the one on the left, okay, let me grab my little marker. If you look at this edge right here, you see how that's flat. And what that does, that allows the webbing to actually stay flat as it's going in there and not distort at all. Also, the webbing itself, the webbing on the lanyard itself is a heavier duty. It's built differently to withstand more of the sharp edges. On this one right here, on the one on the right, you'd actually take that carabiner and hook it up into the O-ring. So you'd actually tie it back upon itself, and that's how that works. Again, these are great tools for when you have to do that, but you have to make sure you have the right tool for the right job. When you start looking at selecting an anchor point, a couple things to think about. If you're using a lanyard versus a self-retracting lifeline, I'm going to take a step back. Self-retracting lifeline, I don't have the picture of that on here, but what it is commonly called a yo-yo, commonly called a retractable. What it does is it pulls the lanyard or whatever it is back into the hub, but it snaps back or it locks up very, very, very quickly. So if you look at the person on the left, if they're going to fall from the point of that anchor. They're going to fall 6 feet because it's a 6-foot lanyard. They're going to fall up to an additional 3.5 feet because that's how long the deceleration device is. So when it's all said and done, that lanyard is going to extend 9.5 feet from wherever that anchor point is. Well, with a self-retracting lifeline or a retractable, it's actually going to be usually less than 2 feet, so it's going to catch very, very quickly. Now, if you do all the math, you start showing even more important of why it has to be. So you have your 6-foot fall, or the 6-foot lanyard we talked about, a 3.5-foot deceleration device. But if we also stop to think about where you tie off to, you tie off to your back, which is on average about 5 feet from your feet. So if you would be at the 9.5 feet, your lanyard would fully retract. You're still going to end up hitting your feet, hitting your butt, etc. So you throw in an extra 5 feet to your D-ring, the back of your D-ring, and then you throw a safety factor in with some harness stretch to it. You're talking 17.5 to 18.5 feet. And that's the problem with using a lanyard for everything, is you don't necessarily have the clearance. So if you're looking from the point of anchorage, you need to have 17 to 18.5 feet of clearance. Now with self-retracting lifeline, you need 2 feet. I mean, that's what makes that work as well as it does. There's some tools out there. Fall clearance calculator, Miller has one, Capital Safety has one. There's apps out there that you can use to help. Okay, we're here and we're at this height. This is what device we should use. So we talked about your ABCDs. So we talked about anchor, you talked about your body harness, your connector. Now we have to talk about descent. Whatever goes up has to come down. So if you have somebody up there, you have to have an idea of getting them down. I do a presentation on rescue. A lot of people want to use the fire department, but the fire department, if they may not have ladders tall enough to get to them, and they may not be trained in rope rescue, And even if they do have a lot of that stuff, it's going to take them a long time to get set up, or you're not going to be able to get a fire truck close enough to actually get them anyway. So we have all kinds of different options. We can do ladders, keeping it really, really simple. Keep a ladder, a man basket, a scissor lift, getting a scissor lift up to that person, or self-rescue. I think that's the next. This video actually shows a self-rescue device. All the manufacturers are using these in one way, shape, or form now. So that's another option. Again, if you're just dealing with low work, that may not be an option that you need to use. But if you're dealing with really, really high work or difficult areas to get, it's definitely an option. The other thing we're going to talk about with this is our trauma straps. There is a phenomenon when you fall and you're being held by the harness where the blood is actually going to be blood flow is going to be inhibited in your lower extremities. The femoral straps or the leg straps are actually going to pinch off your femoral vein, not allowing blood back into your core. Eventually, enough blood's going to back up. You're not going to be able to get oxygenated blood back, and you can cause a lot of really, really serious problems with that. So here is a video to demonstrate some of the options that are out there.
Hello, I'm Tracy Lyon from Fall Protection. This is Ray Shook. We're going to spend a few minutes demonstrating the proper use of relief stuff. I think the first thing we should do is really explain why you need to wear one, why it benefits you. The problem is orthostatic intolerance or suspension trauma. Now, if you fall in a harness, what can happen is that if you're suspended for a few moments, you'll actually start to become dizzy and naturally pass out. If you're not rescued quickly enough, it can be a dangerous situation. The best way to demonstrate that is you've all seen videos of the bridegroom standing on the altar. He's standing there with his legs dead straight, he's not moving an inch. After a few minutes, he just simply faints. That's orthostatic intolerance. What's happened is that the blood is actually drained from his brain, gone down into his legs. If he doesn't lose his legs, the muscles aren't pumping the blood back out, so that actually will pull into your legs. What happened is, as that man has blood pools in his legs, or strains in his brain, he's simply fainting. He's embarrassed, in a few minutes he'll recover. You're hanging from a harness, and the blood pulls in your legs, and you faint. You can do nothing to help your own rescue or help your rescuers. The release step is actually designed to preclude that from happening. I'll install it on this harness. You go from the back strap, simply a loop on this end of the piece. You put the unit through the loop. Pull it to make sure that it's snug, and then I'll let Ray actually do the rest of the attaching on this. This
This will fit on virtually any harness, as long as you're attached to the back strap itself. It can also be used on multiple harnesses. So if you change harnesses for whatever reason, you can have it on multiple harnesses. We'll demonstrate in a second where you're actually hanging from this, so we can show you how it's deployed and then how you deploy it. Okay, you can see we've got Ray hanging here now. It's not the most comfortable, but at least it's safe after the fall. What Ray's going to do is he's going to grab the release step and just unsnap it from himself. Then he's going to pull the tack off the outside of the back. That's stop from swinging. What you see is the step is now been deployed. Let's leave that for Ray to do. I'm going to ask Ray to put his other foot in. We'll go on the right side. He's probably put his left foot in. This helps a little bit with balance. What Ray will do now is on the outside, there's an orange tab on it. He'll simply bend his knee and pull down on that strap. What will happen is that will shorten that up. Now he can actually stand the opponent. And what that does is move his leg, pump the blood from his leg back up into his heart. Now we put a second release step on the same harness. You can use both. It adds a little bit of comfort. We'll try to deploy the second for a second. Makes it just a little bit more comfortable. One will work, it will stop with the second harness and have it. The two just will have a little bit better balance. Now what you'll do, Ray, is you'll put the other foot into the stirrup. You tighten that down the same way. And you stand up. What happens is you see it takes a lot of the weight off the back of the harness. So physically it's a little bit more comfortable. He's able to actually stand. More importantly, it allows him to get the blood circulating in his legs. And that'll keep blood flowing to his heart and to his brain. At that point, as OSHA requires, you have a plan to be rescued in 15 minutes. 15 minutes like this with no problem whatsoever.
So this is one of the two main manufacturers out there. This is Miller Fall Protection. DBI Sala, they're owned by 3M now, is the other one. Their system is similar, except instead of two little stirrups to get your feet into, there'll be a hook and loop system, not like Velcro, but like you'll have a hook in one strap, loops on the other strap. You put the two of them together and you step in them. Both do the exact same thing. Both have pros, both have cons. So you kind of choose what works for you, what system you like. When we start looking at inspections, your personal fall arrest system and all of your equipment that goes with it has to be inspected by a competent person annually. And the definition of the competent person is really important. It's that they've been trained to identify the hazards and they have the authority to take something out of service. And you really have to have both of those. This training a lot of time will be 8 hours, 16 hours, but it has to be done. Your harnesses, if you talk about how long they're going to last, it's really up to the manufacturer. Some will say it can be done as you have to replace them in 5 years. Some of them will say that as long as they pass a competent person inspection, that you can use them indefinitely. Some environments are so rough that you're going to have to replace them. I did some training. I was a student, but I was with some people working offshore down in Houston, people that would work out on the oil rigs, and they replaced all their fall protection equipment every 6 months, just because of the severity of the environment. Stuff would break down that quickly. You also have to have pre-use inspection. It's required. It doesn't need to be documented, but how else do you really show you did it? So it's just something to think about. Miller Fall Protection has a really good guide to show how to do that. Skip that. A couple of other options that are out there for fall protection. One is a controlled access zone, and this is usually on roofs, but this is where you're going to have an area that's going to be flagged off and you can't go in there. It has to be at least 6 feet from the leading edge, though. That's the important thing. If you go beyond that 6 feet, you have to be tied off. With this, it has to be flagged or has to be marked every 6 feet. 39 to 45 inches high. Those numbers should sound familiar. They're the same height that the guardrails are at. 200-pound braking strength also should be familiar because it's the same that the lateral force of a guardrail system, and can be used instead of a guardrail. What you typically see is this is the flags, the multicolored flags that you see around a rooftop. Next option would be safety nets. So you see here, this is the helipad at St. Vincent's Hospital in Green Bay. You can imagine if you had guardrails up there, that could probably be kind of a hazard when you're bringing helicopters in, so instead they put safety nets all over. So if you are using safety nets, a couple rules. One, you have to must be installed as close to the work as possible, but no more than 30 feet. The distance is important. For one, if you're falling into a net, probably don't want to fall 30 feet. You probably want to fall a closer amount. But sometimes you can't. Sometimes just the way you have to be done has to be considerably lower than you. Also, the safety nets have to reach out from the surface. So if you start looking, if you're going 5 feet below you, it has to go at least 8 feet out. More than 5 to 10 has to be at least 10 feet out, and more than 10 has to be 13 feet out from the edge of the working surface. So even if you're falling, you fall off to the side, it's still going to catch you. Border ropes, they have to have a braking strength of at least 5,000 pounds. These aren't nets that you're building yourselves. You're buying safety nets for this purpose. Connections have to be at least as strong, have to be at least 6 inches, must be at least 6 inches or closer together, and openings have to be no more than 6 inches on any side or 36 square inches total. So there's some of the rules for safety nets. And you have to inspect them every week, and then after any incident that could cause structural integrity. So if you have somebody fall into it, you have to make sure you test it. Also, you have to do drop tests. You have to do a drop test after installation. If you move them, if you repair them, and every 6 months after that. And that test is done with a 400-pound sandbag from the highest work surface. You got to make sure it doesn't fall through. If something does fall in, you have to get that stuff out. So somebody drops a wrench, you have to have a plan to get that out as soon as possible. Fall protection on ladders, it's not necessarily required on ladders as long as you're using it appropriately. So you're not reaching off to the side, you're not stepping on a top step, etc. Then you don't need to wear a personal fall arrest system on a ladder. Now, with fixed industrial ladders, if the length exceeds 24 feet, then you have to have one of two things. You either have to have a ladder safety device, you have to have a self-retracting lifeline, or you have to have rest platforms every 50 feet. You have to have the 150 is if you're using a ladder safety device. Or, I'm sorry, a rest platform every 150. Or you can have a cage or a well around it, but then your rest has to, you have to have a rest platform every 50 feet. The problem with that cage or well is if you fall with that, it's not going to stop you at all. It's just going to keep you close to the ladder. So that's something to think about with this. Then talking about scaffolding, as we mentioned at the very beginning, you have to have some sort of fall protection required after 10 feet. This can either be with guardrails or you can use a personal fall arrest system. Guardrails is probably the most common. Like with this picture, you get up to a certain height and you'll go and put the guardrail system around it. Cross bracing, you can barely see it on the bottom of this picture. Let me grab my marker again. A lot of times, if you have a platform, you'll have a cross brace like this. You can kind of see it here and here and a little bit here. As you're building it, if you have scaffolding above, you have your cross bracing to hold it all together. This can either serve as your top rail or your mid rail, but you have to put another rail in there somewhere along the way in order to make it compliant and safe. Area lifts are only required on scissor lifts when your feet are actually leaving the ground. If you stay on the feet, if you keep your feet on the decking and you're not leaving the ground, you're not putting your feet up on the toe board or anything else, and the guardrail is completely enclosed, they're completely guarded, including a safety chain or the gates closed or whatever it is, then you don't need to wear one on a scissor lift. Some companies still require it, but it's not one of those things that's absolutely, it's not required by OSHA. If you were in a boom lift, you do need to wear a personal fall arrest system at all time, And a self-retracting lifeline is preferred over a lanyard for the reasons we talked about before. If you're using a lanyard, you have to be really 17.5 feet in order to really have that work. Training requirements, you have to provide a training that understands, that makes sure that employees know the fall hazards and knows how to take the proper precautions. That competent person also has to be trained in the nature of the fall hazards in the work area, how to put up, take down, and maintain and inspect all the fall protection systems, and what the role of each employee, and how to use all the equipment. So there's a lot that goes into being a competent person. Has to be written certification, has to include who it is, who's doing the training, the date of the training, and also we have to retrain anytime there's a change in the workplace, change in the system, or there's an inadequacies found in an employee's knowledge. Usually that last one means that they were found to be doing something wrong. You have to retrain them. You're going to find these three, they are the requirements for every single training standard OSHA has. If there's changes, if there's a change in the equipment, or you see the person's not using it right, you got to retrain it. So that is kind of what we have. So that's fall protection kind of in a nutshell. So if you have any questions, please let me know.